Good day. Today we are here at a prestigious golf resort. We are going to have a look at the installation of the heat pumps, the Stiebel Eltron German heat pumps. Come follow me, let's have a look. One of the important features with these machines is that it's quite visually easy on the eye and that it blends with most of our installations. Here you can have a look. This is the heat pump that supplies the hot water to this house. Quickly to explain the principle. It takes the energy out of the air. We do it by harnessing the air. It's got vents underneath over here. We harness it, we suck it in, we put it through a refrigeration cycle. We harness the heat out of the air. And once the heat has been removed from the air, we actually draft it out on this side here in the form of very cold air. Now the difference between the warm air going in here and the freezing cold air coming out there, that energy that we have taken out of the air, we're converting it or actually transferring it via a refrigeration process into water. And this water is then circulated with normal circulation pumps into the house, into the geyser tank. Alright. If you can just quickly come have a look here, I want to show you how quiet this machine is because you're running at the moment. You actually have to physically hold something underneath. What you are hearing at the moment, or if you can even hear it, is you're actually just hearing the draft. You're not really hearing the compressor run. This is quite a feature, especially if you're going to build this machine next to your neighbors or next to a development where people would complain about noise. Let's quickly go have a look at the water tanks. The beauty about the heat pumps is that they work by themselves. You don't need solar panels. We've got some installations where we've added solar onto the heat pump system, but this one works independently. These are the tanks that we're using, that we're circulating to the heat pump and back. There are two 300-litre tanks for this house. It's quite a big house. And you can't see the pipes behind here, but when we get to another installation, I'll give you a detailed view of how these tanks work. The beauty of this system is that inside the bottom of these tanks, we've got built-in solar heat exchangers, or heat pump heat exchangers. We circulate the water from the heat pump through the heat exchanger, and by doing this, we don't mix the municipal water with the water that is circulating between the heat pump. So now from the outside, we're taking the hot water that is generated via the heat pump. It circulates through the bottom in heat exchangers which are in the bottom of the tank. These heat exchangers prevent the municipal water mixing with the heat pump water. By doing this, you never ever get contaminants inside the heat pump system, which means no maintenance on the circulation pumps, which means that your system will last forever. That is the idea behind it. Alright, let's go to the next house. Let's have a look at the next heat pump. Follow me, let's go have a look at the second heat pump. This is just to give a bit of a demonstration of how these machines are pretty adaptable. You can put them anywhere outside in your garden. They blend quite nicely. It's really a visual feast. We've come with two colors. You get the white one and then you get the gray one. It's got a chalk powder coated gray cover. So really we can fit them into any type of garden, and they blend quite nicely with the house and the features. Similar process, air is drafted in on this side of the heat pump. The heat is absorbed out of the air and the cold air blows out on this side here. Alright, we had another installation now where we have actually combined solar, heat pumps, pool heating. We're going to just quickly have a look here. At the top there, you can see on top of the house, you can see two banks of solar panels. These are water-based solar panels, not PV, not electric. We circulate glycol through those panels and we take it down into a boiler room, which we can have a look at this now. Follow me quickly. Let me just show you the pool that we are heating. Once the demand inside the house has been met as far as central heating and as far as hot water is concerned, we take that heat or that excess of heat and we actually dump it down into the pool. There's a heat exchanger between those solar panels and the pool. So we pump the pool water through the heat exchanger, and that heat or whatever surplus heat that we have left over, we pump back into the pool, which results in a very nice warm pool. This is quite a bit of a marriage to marry these systems, but I will show you now. Let's have a look inside the house. Alright, we're going to go inside the house. Follow me. Let's go up to the boiler room where I can show you where everything happens. These are the convectors that are actually used to heat up the house. Once we've harnessed the energy from the solar panels or excess energy that we have left over, we put it through the boiler room, which I'm going to show you this now, and then that heat is transferred via water pipes from tanks down to the convectors, and we've got these convectors located all over the house. Let me show you quickly. We've got one of these convectors located in every single room of the house. Now the beauty of these convectors is that they do heating and cooling. They've got a functional pad on the inside like a normal thermostat that you would find on an air conditioner, where you can adjust your room temperature and automatically the machine will switch on heating or cooling depending on the temperature that you've set to the room. So it's pretty self-regulating. Okay, let's go upstairs. As you will see, here are the convectors located in different parts of the house. Alright, come have a look at the boiler room, where the magic happens. Come through, let me show you from the beginning. These big tanks that you see are the storage tanks that hold the water. These tanks, or the water that's inside the tanks, actually stores the energy. It's our way of transferring energy from one section to another, either from solar or from the heat pump or to the pool. Alright, let's start with this tank. This is your domestic hot water tank, like the normal geyser that you would have in any other South African house. Once we take the energy from the sun, from the solar panels, we bring that heat down through glycol into a heat exchanger. The heat exchanger for the solar is located in the bottom half of the tank. Now this is where the magic lies. This is where we marry the two systems, where we marry the heat pump, where we marry solar. The heat pump doesn't know what is happening with the solar, and the solar doesn't know what is happening with the heat pump. The way we marry these two systems is through the water, the natural ability for water to layer as the temperature increases. Your cold municipal water will come in the bottom, and then your hot water will go out the top. Now naturally, as your water heats up, the density changes and the hotter water will flow up to the top of the tank. The reason the solar section or the solar heat exchanger is located in the bottom is because your cold water comes in the bottom, and then the solar sensors will first sense whether there is solar or not solar. If you don't have any solar, as in the case of the evenings or when you've got rain or overcast weather, cold water will come in the bottom, it will bypass the solar heat exchanger until it gets to the next heat exchanger, which is the heat pump. Now on this automatic layering of water, the system automatically sorts itself, and these two systems marry. If the sun is shining, it's going to heat up the cold municipal water that comes in the bottom of the tank. Once this section has been heated up, it will automatically rise to the next section with the heat pump. But if hot water rises from the bottom and it gets up to the section of the heat pump will sense that the solar has already heated the water. So you won't use any additional electricity from the heat pump to contribute to the final energy inside the tank. This little bit of a marriage where you marry the two systems is the secret of this whole system. It's so simple, but the secret is lying in vertical tanks. You will never ever find a system, whether you go outside South Africa, if you go to Europe or the eastern countries, any alternative energy system consists of vertical tanks, whether it's a heat pump, whether it's a solar system, whether it's a marriage of the two systems. It's always a vertical tank. It is basic science, and it's this basic principle of water layering that we are unable to marry these two systems. The extra pumps and things that you see inside here, this is fancy because on this house what they wanted to do was they wanted to have a centrally located, or they wanted to have a hot water ring main, so that the minute you open your tap anywhere in the house that you've got instant hot water. You don't have to wait for the water to get from this side of the house to that side. So what we do with these pumps is we circulate the hot water to the house, round to every single tap. It's like a hotel when you go and stay at a Protea hotel. If you've got boilers always located on the 8th floor. If you're on the 1st floor, the minute you crack that tap, you'll have instant hot water. Now this is a luxury, and this is something you don't realize when you go and stay at a hotel. But we are doing this now for the houses, so you can have it inside your house now. It's quite a fantastic feeling once you get used to it, and once you live with this thing. It's unreal. Okay, come around. Let me just quickly show you the solar system. These three pumps here control the entire solar system. This is just a more compact unit showing you the temperatures and the pressures. But what this is in actual fact doing is this heat from the sun goes through the panels, through the glycol, transferred through this pump, and then into this heat exchanger in the bottom. So this complicated pipe network that you see here is just diverting the heat from one section to another. But the secret also is in this computer that we're using. The computer that I'll show you just now controls these pumps individually. It's got a sensor on top of the panel, and it's got sensors inside this tank and another tank here which we use for central heating. Now when the computer senses, it always gives first priority to domestic hot water. When it senses that your hot water temperature is down, it will start this computer. So the minute the sensor on top of the solar panel is a little bit warmer than the sensor in the bottom of the tank. It will sense that there's a temperature differential. It will transfer the heat into this tank. Once this tank is up to temperature and hot enough, the computer will sense the next tank. It's got a sensor in the central heating tank. It will switch over the pumps. This is your central heating pump. Now, once the central heating is going, it will contribute heat to the house. If the convectors are off in the house and there's enough heat in the house, the computer will switch over to the last priority, which is the swimming pool. Inside the wall down there is a titanium heat exchanger which circulates and prevents the pool water with mixing with a glycol system. So you've got lots of different systems here, but none of them are interfering with each other. You've got the municipal water, which doesn't mix with a glycol in the solar system. The glycol in the solar system goes through another heat exchanger, which doesn't mix with the pool water. By keeping your systems pure and by keeping closed systems, you never ever have to replace these circulation pumps. It would be a problem if we had to take municipal water, put it through the circulation pump, because then your pump would go over time and you would have these extra costs. Alright, this is the solar system. Let's go a little bit further back. These two big tanks that you see here next to this domestic tank is for the central heating. This is your warm tank. We call it a warm buffer tank. This is your cold buffer tank. Now, depending on the temperatures and whether we're in the winter season or summer season, this heat pump, via sensors that are located inside the house and sensors outside the house, it will work out whether the house has to be heated or cooled depending on your specifications or whatever you set on the sensor, on the controllers. Now, the solar energy is actually pumped into the bottom, same as the hot water system, and heat is contributed into this tank on the same layering principle. We've got two heat exchangers again, one for the heat pump and one for the solar. Now, if there's enough solar, it will heat up the tank. If there isn't enough solar, the heat pump will kick in. The one problem that we have in this whole industry is that people think that we can use solar to heat up the house. But when you need to heat the house, it's either when it's overcast, raining, or when you're in winter. Then you don't have the solar contribution. Then you need a very efficient heat pump to back it up. The advantage of doing this, or actually using solar to contribute energy into the tank, is for in the morning when the sun comes out, the sun can't penetrate the house. So then we in the morning harness the energy from the outside, from the panels, and we pump in a little bit of energy to the house, which is quite efficient because you're only using a circulation pump to transfer all this energy and you're not using a heat pump. Now, the secret, or one of the secrets to this system, is that this buffer tank is controlled via the computer, in that they'll be changing the temperature continuously. As your house breathes, it's like a dynamic system. As your house breathes, your temperature has to change. If your house is very cold, you need extremely high temperatures to quickly transfer energy into the house. Now, what this computer does via the sensors inside the house and outside the house, it works out a heating curve, and that heating curve tells us what temperature to make this tank. If you get a moderate day like this now and you want to just warm up the house a little bit, this computer will drop the temperature of this tank down to say 30 degrees, and we'll transfer 30-degree water into the house. And this is the secret with heat pumps. The lower the temperature of your tank, the higher your efficiency. If you take a crude heat pump and you screw 60-degree hot water and you push it into this tank, your efficiency is going to drop way below 50. Now, if we can drop the temperature of the tank down to say 30 degrees, then you get efficiencies of almost up to 1 to 5, 1 to 6. That means every unit of electricity you pay Eskom, you get 6 units of free energy out of the air, and we're transferring it into the house. And this is not solar, this is just the heat pump. This is the secret of the heat pump. The heat pump is already such a very efficient system. We are marrying the two systems here to give the best, the Rolls-Royce of energy systems. This is just a straightforward cooling tank. It's for the summer season, because the people have already got the infrastructure in the house to do heating, so we may as well transfer this via the convectors into cooling. When you switch the heat pump cycle over, we go from heat pump to cooling. That's exactly what a heat pump is. A heat pump is a fridge in reverse. So when we are not doing heating, the cycle inside the refrigeration system changes over and we do cooling. So using one compressor, we are combining a system with solar, with pool heating, central heating, and cooling using one compressor. This is Stiebel Eltron's magic. This is German technology at its best. Alright, come have a look here quickly. Let me just show you. This is how we use one compressor to heat up the different tanks. That computer, which I'll show you just now, switches on these different pumps same way that the solar switches it on. So if we want to do domestic hot water heating, we've got no valves, no changeover valves, nothing. It's just the pumps that switch on depending on the demand. So if this pump switches on, obviously the flow is going to go to the right tank. Same with this thing, which is used for the central heating. Alright, let's have a look at the heat pump. We are very lucky in that it's busy running at the moment. I'm going to be quiet just for a second. You can hear the difference between my voice and between the noise that the heat pump makes. This is pretty important because our internal installations are always located next to a bedroom. And you cannot have any noise or hum or vibration transfer from the heat pump through to your bedrooms, otherwise the people won't sleep at night. Alright, let me open up the cover and you can hear the difference. You can also take a peek at the compressor. This is the Stiebel Eltron heat pump. There's our one compressor which we are using to do the heating and the cooling. It looks like a little bit of a nuclear plant, but this is a compressor that has been specifically designed for Stiebel Eltron with vapor technology. It's a vapor that actually cools down the compressor while it is busy running, but we'll get into that in another video. You can actually see the heat pump at the moment is busy cooling. You can see the condensation coming on the pipes here. You can see the water. You've got to lag all the pipes here with this insulation to prevent the condensation coming off. So at the moment it is busy cooling the house. This is the heat pump computer. Let's just take a quick peek. This is the brain for the heat pump. This computer only controls the heat pump operation, the refrigeration operation. This is actually the computer that connects to the heat pump that controls the rest of the house. Alright, I'll explain this a little bit more now in detail. This is the soundproofing that has been put onto the heat pump. You can see it's quite thick, it's quite considerable. And this is why once this cover is on, there's virtually no sound left over. Much better. Now, this heat pump is exactly the same as the heat pumps we saw earlier on in the video. The only difference is that the same box gets a different hood. That other hood where we drafted air in on the left and expelled it on the right, we changed that hood now and we put an internal hood on. Now we're sucking the air out of from the outside. It gets drafted through the heat pump and it gets expelled out the side on the other side of the house. So it's exactly the same machine with a different casing, with a different memory. Alright. This is the heat pump computer. This is the baby that is doing all the calculations at the moment. It's actually sensing the temperature inside the house. It's sensing the temperature in the tanks. It's running the heat pump. It's marrying this entire system and keeping it in a dynamic process where it is continuously changing according to your outside weather and your inside weather inside the house, and it's automatically regulating the pumps. The bottom computer, which you can see over here, is our solar computer. Today it's a little overcast, so we've got 40 degrees on the panels. Our hot water is already at 46.2. When the sun comes out this afternoon, the temperature will go up and it will heat up the different sections. This computer controls those pumps, which we had to look at a little bit later. Here we've got the internet connection where we can see exactly what is going on inside this heat pump. Every pressure, every temperature in this entire system on the refrigeration side goes through this computer and then is transmitted over the internet. So I can see anywhere in the world, even the supplier, if there's a problem or if I don't understand something, the supplier in Germany, I'll give him a call. 2 minutes later, he will go onto the computer, analyze this entire refrigeration system and tell me what is going on. This system expands with sensors as well, that he can even tell me what is going on inside the tanks or inside the house. It transmits the outside temperature. Every single little bit of information is transferred via the internet, which is pretty fantastic. So if I ever have a problem, we can phone the technical guy in Germany. 2 minutes later, he can pick up the phone, tell me what is wrong with this thing and what we have to do on the ground over here. So the people who go around doing the installations, they don't have to have the technical background. These pipes are the pipes that transfer all the energy that we've gathered now, whether we transfer in cold water or hot water from the tanks. We transfer it into the house. At the moment we're transferring it to convectors that I showed you a little bit on earlier in the movie. But On the same principle, the same pipes can be diverted to manifolds which transfer the heat and the water through the underfloor heating. All the new houses are being built with pipes where they put in the cement, and we take this energy that we've already got so efficiently and the heat that we've harnessed out of the air, we transfer it through the same principle, through the same tanks and back into the water manifolds. And that heat is then transferred into the house, which gives you underfloor heating without using electric wires. And finally, this is the diagram which I'll put on at the end of the video where you can have a look at it, showing the whole system. This is just basically the water pipe layout.